Hello, good morning, good afternoon, and good evening based on at what time you are listening this and where you are at this time. My name is Anuj Mohan, as you see in the screen. Uh, I'm going to present today run mixed workloads on Exadata with Oracle 12c released two new features. Uh, I belong to Oracle ACE community. I work for data intensity as technical account manager. I have done a couple of certifications, which is on the screen. So this is pretty much about me. You can follow me on Twitter, and my Twitter handle is Anuj Mo. So with this, we'll start. Um, as I said, I belong to Oracle ACE community. ACE program is a very good community recognition program, and you have some information. If you have any interest, you should be checking it. So a little bit about data intensity. We are a global company, and we have various verticals where we support our customers like database, application, and BI analytics. And other than that, we got a big engineer system practice, and we have various delivery models also, like professional services and managed services. Um, and we have our own cloud offerings also. So pretty big company at this point. And if you look at this slide, this shows how we support our global customers on a 24 by 7 basis because the way we are spread on the globe. With that, I'll begin today's presentation and I'll start with some business needs. So one of the business need I have is I want to consolidate multiple databases into one database as schema consolidation. I have same name public synonyms in those databases. I have a large table around 1.5 terabyte. Some of my queries need to do a full table scan. It is not possible in my database, so we block those queries. Then I have three tables, which their sizes are 50 gig, 20 gig, and 150 M. We load data on a nightly basis and delete data on those. And my users write ad hoc queries joining those tables. It is difficult to keep up with needed indexes, and adding a lot of indexes also slow down data load. I want to consolidate multiple databases into one server. How I can make sure that one runaway query will not take over all my CPUs or database resources or IO resources. I have a federal state regulation to keep 10-year worth of data online, wherein only we use current years of data frequently. Occasionally we use data 3-year-old, but use of data older than 3 years is rare. But a state regulation says to keep 10-year worth of data online. We clone multiple environments every month. With growing database sizes, work window is increasing. Ad hoc queries sometimes cause nightmare. How do I know if I have a room for growth in my Exadata? So these are regular business needs. They are problems if you do not have a solution, right? And with this, I'll talk about today's agenda. So we talk about some of the problems, which are actually not a problem, but a common business needs. They are problem if we do not have a solution or if we do not do something about it. So Today's agenda is I'm going to talk about some key 12.2 multi-tenant features. Then I'll talk about 12.2 in-memory features. Then I'll talk about some Exadata key features. And at the end, on the fourth topic, we talk about few business cases. Those business cases are nothing but solution to the problems we talked about, or solution to the business needs we talk about. And let me give a quick disclaimer. I am so sorry, but this is a large presentation, and I'll be covering 80 to 90 slides um, in next 50 minutes of time. You're welcome to ask questions using chat feature, and I'll be answering them. In the last slide, you'll have my email address and my Twitter handle. If you have any follow-up question which you want to ask, you're more than welcome to do that, and I'll be replying as soon as I can. So with that, let's start with multi-tenant features. So I assume you understand about the multi-tenant architecture. Initially, it says that the undo will be also shared, but with 12.2 we came up with local undo, and it gave us an opportunity to utilize some new features which were designed because of the local undo, like PDB flashback, PDB relocate, and refreshable pluggable databases. So what is flashback? It's a true flashback. You do not need a auxiliary location. All you need is the local undo enable. Check that the flashback is on in the database. And if you see on the lower part of the screen, some simple SQL commands. I'll not be reading the commands. They'll be for your reference. So then I talked about local undo and flashback, and now refreshable clones. So you create a clone and you can refresh it. You'll have two options, whether you can manually refresh it or you can refresh it automatically. So with the manual refresh, you have to use alter pluggable database PDB1 refresh. In automatic mode, it will done itself, and you can have any duration you want to refresh. For an example, here I'm using 5 minutes. You can have 1 minute or any increment of minute. So this is a very neat feature. Could have you could think of multiple cases, business cases of using this feature, right? Then clone. In this example, I'm trying to clone a PDB Anuj on CDB1 to Mohan at CDB2. It's the 12.1 where we had to keep the pluggable database, source pluggable database in read-only mode. 12.2 gave an option of hot clone. So in 12.2, when I'm trying to do the same thing, I do not need to take my PDB into read-only mode. It can be open in read-write mode, okay? And then I can run the clone command. There are some restrictions with the star, like the Indian format character set must be compatible between CDBs, database link. You'll be using database link for the communication between CDB1 and CDB2. So we talked about refreshable clones, we talked about hot clones. The next thing they did is and this example says if I have to do a hot clone within a single CDB, I can do that too without taking the source PDB in read-only mode. So I keep the source PDB in read-write and still do the clone. So hot clone and refreshable clones, two new features, and they combined both features and came up with a PDB relocate because I can refresh clones and I can do a hot clone. So I do a hot clone and on top of that keep applying the refreshable thing that both features join together called PDB relocate. So you can live relocate a pluggable database from one CDB to another CDB. All you need to do is create a database link between CDB1 and CDB2 and run a simple PDB relocate command. Okay. So here is the SQL statement, how you do it. Create a database link between CDB2 on CDB2 pointing to CDB1 and run a relocate command from CDB2. Right? So then I'm consolidating multiple pluggable databases on a one container database. Then I'll be thinking, oh, how do I manage the resources? So the good news is there are parameters which I can set on a PDB level and control the memory resources like DB cache size, SGA target, SGA min size, PGA aggregate limit. All those parameters I can set on a PDB level. Right? Okay, so now with Tool.2, they gave an option to control I/O also on a database level. So this was earlier, this was only allowed in Exadata, but 12.2 has an option that you can control I/O operations also. So max I/O ops and max MBPS. You can control it. You can define it in a PD level and it will and give a I/O limit. Okay, there was an important thing which I missed. So if you define something on a PDB level, it takes precedence over the setting on the CDB level. There was a new neat profile for the on the security level. It's called lockdown profiles. Basically, you need to have a create lockdown profile system privilege to do that. It's pretty easy to implement and has some real good use cases, particularly when we're talking about moving to cloud and opening it for keeping it in a shared architecture or keeping it accessible to more users easily. This lockdown profile is a really neat feature, and it's pretty simple also. So what you do is you create a lockdown profile. For in this example, I'm creating a lockdown profile HR prof. What I'm doing is alter lockdown profile, enable a statement, alter system with a clause plus shared pool. Second statement, I'm disabling the statement alter system. So when I grant this HR profile to my PDB users, they will be able to flush the shared pool, but they will not be able to run any alter system command, which is kind of neat because if I gave an alter system, then I'll be giving a lot, which I do not want. I just want them to be able to do a flush shared pool, and using this feature can be done. Okay, so application containers, that was also a new feature in 12.2. And what this feature is, until this feature, there was no way to define application within the pluggable databases. So if there is an application definition, and there was no way to define it within the pluggable database. And so with keeping that in mind, we came up with this feature. And let's talk about it a little bit more. So till this point, if you see the screen, architecture is exactly same as multi-tenant pluggable architecture. But with application containers, they added an app PDB root, right? So far it is same as any other pluggable database, except that it is a root. And how you create it? You use as application container clause when you create your app PDB root. Then you want to install your application, so to install you use like begin and end install clause. Then you clone it, and you want to synchronize it, so then you'll use the sync clause, right? And this example will make more sense when what I'm talking about. So in this example, what I did is I created an application container, right? Application PDB. Then I opened application container because by default it's an amount stage. Set the current container. And then I started an application install with begin install clause here. Here, begin install. Then I did all my DDLs and DMLs, which is an application installation process. Then I did an end install. Right? When I do a clone, I'll be exactly cloning the installed application. So I need to set the current container and do the clone here, and then open it. At this stage, I created a clone. I distributed it to different places where it is supposed to run. And if I created 10 clones, and then there was an application patch where I need to run few updates, few alter on the table, which was a modification in an application. What I can do is I can run all those updates on a application container, and then I can run a sync, and it will be replicated to all pluggable databases. It's kind of a neat feature. If you're running a small SaaS applications, this is the way to go. Okay, so I talked about this neat feature, application containers. Unfortunately, there was a limit that the scope was within a single container database. And if the scope is within a single container database, then actually it does not make a sense to use this feature, because what is the point if you're running all your application clones in a single container database? So to overcome that problem, they came up with a new concept called Proxy PDB. And basically what you do is you create a proxy pluggable database of your application container, which is in a CDB1. Your proxy PDB will be in a CDB2. And then this proxy PDB will become an app root in CDB2 for those clones. So this proxy PDB will be local, and then I should be able to run the sync. So with that, I'll move to the next section of in-memory features. So we talked about some neat pluggable database or multi-tenant features. The next section is in-memory. Oops, excuse my bad graphics here. So what is in memory? Traditionally, data is stored in row wise, which is good. If I have to take the whole row out and do some transaction, which is typical OLTP transactions. But analytical queries usually access a fewer columns. And if I have to take out a whole row with 35 columns, wherein actually I'm in need of 2 columns, it's an expensive way of doing things, right? So after 12.1, there was a IM patch given which you apply, and you should be able to use in-memory column store. And so if you're using in-memory column store, you can store data in a columnar format within in-memory, and Oracle will manage it transparently, and Oracle will maintain transaction consistency, right? So your data is uh, in row format and column format both. The next thing is why using in-memory, what benefit it gives. In general, before in-memory columns, so even you put a table in a cache, you'll get benefit of memory because you do not have to read data from a slower disk. That was benefit number one, which was always available if you're putting something in the memory. But now you get efficient joins. Um, Columns in memory have a smaller footprint as they are compressed. So you get some compression benefit, which I'll be talking about in the following slides. Right? It uses a SIMD. SIMD is single instruction, multiple data. So there will be less CPU cycles and you get a performance benefit. And and you can do an in-memory aggregation using vector group by class. Excuse my graphics, I do not know why it expanded and not coming clean, but it's a 12.2 feature in memory for active data guard. So you can create your in-memory column store on active data guard size, and all you need to do is set the in-memory size on active data guard, right? Very neat and very useful feature. You can have a different in-memory column store on primary and active data guard. All you need to do is create service to access primary, create service to access standby. And when you define uh, in-memory attribute, you need to use the clause in-memory distribute for service. So the service you created, if you say service is data guard, or if you say service is primary, then it will be populated on a primary or data guard side. So very neat feature. And then you can have different in-memory column stores on active data guard and primary, or you can have on your IMCS only on active data guard side, but not on the primary. So pretty flexible there. So something is in memory, and then how you decide like it'll remain in memory or phase out. So there was an implementation of heat maps. Data frequency access is tracked. Data will be added or removed from in-memory column store based on the temperature and memory pressure, actually using heat maps, right? It can be user defined too. Excuse me. So if you are using the automated mode, like all you need to do is set heat map on, memory ADO enable true, and it will only work when there is a memory pressure, which is like your in-memory column store is 90% or more used. If you want to change this thing, then there is an underscore parameter IMADO mem thresholds, and you can set it to a different value, say 80%. Then it will kick in at 80%. I do not see a reason why you want to do that, but if you want, then it is there. Okay, so if for some reason you think now you want a better control, then you can implement heat maps using policy also. You need to create the ADO policies, and here are some example of creating ADO policies. Here, what I'm saying is alter table Anuj ILM add policy no in memory after 10 days of no modification. So if my table had some modification, then I'm expecting that it will be still accessed. To keep it in memory. This is not the very good example, but it could be a case. The next one is alter table Anuj ILM add policy no in memory after 120 days of creation. So if I know like if the table will not be in use or will be accessed very rarely after 4 months of use, then I can create this policy. These numbers can be anything, right? If I know that table is not accessed for 25 days, then it will not be accessed anymore. So I can create this kind of policy, the last one in my screen. Alter table Anuj ILM add policy no in memory of 25 days of no access, right? So this is policy. This is heat maps using policy. And now I'll be talking about join operations, Bloom filters. What is Bloom filter? When you're adding two tables in where clause is on a small table. So where clause will be evaluated first. The result set of the first operations will be transferred to the bigger table for a scan. So basically, Bloom filter converted your multi-table join into a faster scan operation. So they are pretty fast than the regular joins. But the condition number one, that where clause on a small table cannot be the case. So if you're not able to use Bloom filters, you can use a hash join. And here in this example, I'm trying to do a hash join between vehicle table and sales table. And the way it works is, it will scan the vehicle table, decompress the rows, build the hash table based on the above data, and then scan the table, scan the sales table, decompress the matching row, and prove the hash table using the join column. So there are quite a few things which it need to do a hash join. It's still a very efficient way, but it has 4 steps. 12.2 gave a new feature, join group. But you do not need to build a hash table. You do not need to scan the table. You do not need to match the rows and uncompress the data in the vehicle. All you need to do is run this using join group, and it operates on a compressed data one thing. Database will institute array instead of building a hash table. So there will be no hash table created. It will be just an array. So it will be simple select based on the join group. And the way it works is, within memory, you join the tables using symbols. So if you use the same symbol for 2 columns of different tables, then essentially when you have to retrieve data using joining that column, then using that symbol which you use for joining those two columns will have the memory address for both tables records. And the join group is pretty efficient way of doing it. Then in-memory expressions. So say if you want to have some expressions, you can have it. It's like a virtual column, and it'll be pre-calculated within in-memory. In this example, I am trying to do calculate the weekly salary and annual compensation, wherein in my original uh, table I had salary and commission percentage. Based on that, I can create my virtual columns within in-memory as an expression, and I can store them, keep them pre-populated, so my queries can access it. And here are few processes which were uh, responsible for doing this. Um, there are views which you will need to access in order to uh, verify if expression is being used, what virtual columns are created, and what kind of benefit you are getting. Procedure to add expression, DBMS in memory, IME capture expression. You can drop it if you want to drop a single expression, or you want to drop a group of expressions. Based on that, you can use one of the uh, IME drop expression or IME drop all expressions method of DBMS in memory. Okay. So in memory column store, now you can store in Exadata Flash also. Smart scans get a in memory benefit. So and as you know, like you have a lot bigger flash than the memory you have on the machine, so you can have a very big in memory column store. It's very easy to implement, like alter table Anuj cell memory, alter table Anuj no cell memory at the create time. There was one limitation that you'll be able to utilize it if you're using ESCC. I think it's going to be removed in 18C. I am not positive at this point. But if you're using ESCC, then it's a really neat thing to use. And you can monitor the usage with cell memory IMS scans column. Just to give you a quick glimpse, even if you're using an 8th rack, you have 38.4 terabyte of flash in a high capacity mode. If you are using a extreme flash option, then you'll have 76.8 terabyte of flash. It's a lot of flash. It's a raw. Even if you do triple mirroring, you get a lot of flash to use, and that's the lowest configuration. Then if you go on at next level of quarter rack, 76 terabyte of flash, and a half rack 192 terabyte, and 358 on full rack. So that was in memory. Let's talk about Exadata. So it's an engineered system, hardware and software work together. It's a combination of smart Oracle Exadata storage server software, intelligent database software, industry standard hardware components. So everything fast, and then designed to work together. The latest generation is X7 machines. You can go for 8th rack, quarter rack, half rack, or full rack, and there is another option is X7-8, where you get 2 servers, but they'll be really big. So a typical X7 configuration, Eighth rack you get 2 servers, quarter rack you get 2 servers, half and full rack you get 4 and 8 servers. Um, 3 storage servers in eighth rack, 3 storage servers in quarter rack, 7 and 14 in half and full. I already talked about how much flash we get, and in high capacity the storage you get is on an eighth rack 180 terabyte, 370, 360 terabyte and a quarter, 840 and a half, and 1680 terabyte of disk space in a full rack. And on the right side, if you do not want to go with that hard drive, just want an extreme flash, then you see the options. Just to give you some historical perspective, just the prior model to X72, the X62 had 38.4 terabyte of flash in extreme flash, which is doubled. So you can see the numbers and see how X7 is superior than X6. And this is just a tabular configuration. Then there are a lot more things which got changed from X6 to X7, and there is a link for the data sheet. You can review it if you want. All right. So with this, we will start with the first feature of Exadata, which is EHCC Exadata hybrid columnar compression. So as the name suggests, it's a hybrid. Typically you get 10x to 50x compression, and you can get a little bit lower or a little bit higher based on your data. This is a new technology within Exadata, or you said this was a new thing introduced with Exadata. Not anymore, because if you've been following news or blogs, Exadata is 10 plus year old now. So basically what you do is store data in a hybrid format, row and column. Overall picture of EHCC, or overall picture of compression. So within an Exadata, you will have an option to use basic compression, advanced compression, and EHCC, which will be Exadata exclusive. Within EHCC, you can do a query or warehouse compression, or you can do an archive compression. Before you move to Exadata, if you want to check how much compression benefit you'll get out of EHCC, you can use DBMS compression, get compression ratio, use this package DBMS compression and method get compression ratio, and you can find it out. How it works? Basically, table blocks are organized into a compression unit, CUs. And within those CUs, data will be stored in columns. So it will be packed. How many rows will fit in will be determined at the load time. And each column will compress separately. Again, two types of compression, warehouse and archive. So say if you're getting 10x compression, you'll be saving 10x space, but imagine your queries, if one of your query was doing a 50K IO, then it will do a 5K IO. So that will be IO benefit also. And archive compressions may give you 50 to 70x compression. Again, it depends on your data. It may be lower, it may be higher. Some easy syntax. Data archiving strategy. So if you're doing an OLTP, then you should be using partitioning and then archive the compression. Use an archive compression for the unused partitions. Within If you're using warehousing, then you to partition, then use warehouse compression, archive compression based on what partition is how frequently used. Some of the tips on ESCC. Compression advisor may have issues with a uniform table space. Um, if you want to use ESCC in OLTP environment, then you should use partitioning. When you're using data, make sure you use direct path load. DBMS can be beneficial or ACFS, so basically a common storage. And the top benefit you get in the IO bound queries. So database resource manager. This is not new. Uh, you've been seeing this, and basically it's what database resource manager do is it prioritize the resources for database users or group. And it's not only prioritize, it guarantees also that if you can guarantee that this much of resource will be available to this user or group of users. This is a building block for IORM, which is an Exadata specific feature until 12.2, where not the full set of IORM, but you should have some control on IO within pluggable databases. So how you create database resource manager? You database resource manager plan. You group database sessions, users, and services with a common performance goal into one consumer group. And then allocate resources to newly created consumer group. So there are methods how you can do that, like priority, ratio, or hybrid. And then you enable resource plan. That can be done manual or automatic. All right, IORM, which is a typical Exadata feature. So where you control IO resources. Here's a quick example how IORM works. So in this example, if I'm saying I have a requirement that my reporting need 1800 MB per second, my ad hoc queries need 500 MB per second, and my OLTP needs 100 MB per second. If I add up everything, it comes out to be 2400 MB per second, wherein I have an available IO bandwidth of 1800 MB per second already. And these are the numbers which I made. This is not the number which you'll get in your Exadata environment. This is just for the sake of understanding the concept. With IORM, you can control it. Okay, I'll give reporting 1500 MB, ad hoc queries 200 MB, and OLTP 100 MB. Again, these are made up numbers. This can be very different in real world. On a broad picture, your IORM works on within database or within multiple databases. Within database will be intra-database resource management, and if it's a multiple database, then it can be two things: inter-database resource management or category resource management. Two kind of plans here. So I create consumer groups and I create mapping rules. So say I pick like billing, rating, and billing user two as they do a batch kind of operation. Then reporting one and reporting two users do the reporting kind of operation. Then customer activation, customer entry, invoicing is an OLTP operation. So basically I created three consumer groups. Then I allocated resources. As I said, I may have a three options. Method one is a ratio. I said reporting needs 25% of the resources, IO resources that we are talking about here. Batch process needs 15% and OLTP needs 60%. That was method 1. Method 2, I set priority. So my reporting will have second priority, batch process will have third, and OLTP will have first priority. I can do a hybrid method also, wherein I'll say like P1 and P2, priority 1 and percentage, a combination of last two methods. Priority 1 reporting will get 15%, batch process will get 5%, and OLTP will get 80%. Priority 2 will be reporting 50%, batch 40%, OLTP 10%. And if you think these numbers, typically they can be a day and night plan. At the daytime, I do not want to give much resources to reporting and batch, but I want to give a lot of power to OLTP. In the night time, I want to concentrate on batch processing and reporting, right? So that the reports are ready in the morning, batch process is done in the night time, and there will be very fewer OLTP operations in the night time. So I can use something like that. Okay, so IORM, it's again a small graphical representation how IORM works in an entry database plan. So say if you have a queue in finance and orders, like finance high, finance high, finance high, finance low, and in orders, order high, order low queues, right? It goes to IORM, and then there will be a result queue. So the result queue will look like finance high, order high, and this is the way it will be processed. So IORM in a category mode, you basically you create a category. So here I created categories like HR, orders, and finance, and within HR I'll have within HR category I'll have two consumer groups: payroll, benefits. Within orders, new customer, returning customer, and some of reporting. This is just made up thing. You can have any option you want. So how category plan works? So uh, priority based category plan. I can prioritize the category. So OLTP will be very critical. Um, Reporting will be critical, and priority 3 important will be batch process. How they work all together. So on a first level, if there is a category plan, so category plan will be executed. On a second level, inter-database plan will be, and on a third level, intra-database plan will be executed. So just for an example, if I said like resource will be allocated based on the category, and I may have that category spread across 3 databases. So say I got 40% resources because of the category, and then on the second level, I will be distributed to those 3 databases, and say based on that, my database 1 got 20% IO resources. That IO resources on a third level within database, it will be distributed again. All right. Easy feature, instance casing. Basically, I'm restricting database instances to use a specific number of CPUs. So I am not allowing a runaway query to eat up all my CPUs, and it's pretty simple feature to implement. There are 2 ways you can implement partitioning, in and it's sorry partitioning 1, where you partition where you distribute exact number of CPUs to different databases, the number you have on your server. And there's a over provisioning method where you can over provision. You can provision more CPUs than you have on the server. Can work very good in a test and development environment. I would not suggest doing this in a production environment. Very easy to implement. CPU count is the parameter which you can set at the init.ora. On runtime, you can use alter system set CPU count also. All right, smart flash cache. We talked a lot about cache, how much cache we got in new X7. And let's talk about smart flash cache. So Exadata smart flash cache provide caching mechanism for frequently accessed data. Um, Smart flash cache area on a flash disk is automatically created on Exadata cells during startup, right? Um, and in Exadata, you have both flash disk and regular hard disk. Most frequently accessed data on the spinning disk are automatically cached to Exadata Smart Flash Cache, and Exadata software transparently moves hot data to the flash cache. Cell disk made up of flash cache can be used for a smart flash cache. So the cell disk made up of, you can use two ways. One is like a regular smart flash cache, or you can create a grid disk and keep your data. It's an expensive option because you lose space for the RAID implementation, but you can have it if you want to use some real hard data like redo logs or something like that. And storage server software will make sure that only frequently accessed data is cached. Skip data which is not frequently accessed does not cache very big files, and DB can fine-tune caching. You can set the priorities default, keep none for the table index and logs. And here is an example how you do that on the bottom of the screen. How much benefit you're getting out of your Exadata Smart Flash Cache, you can query $systat and, and see how much benefit you're getting. All right. So the last topic within Exadata, storage indexes. And storage indexes are nothing but the indexes on a storage side. Uh, they solve the same purpose, but in a very different way. So um, and it's very transparent. You do not have to do anything. It will all done automatically for you. Um, Basically, it keeps track of minimum and maximum values within a storage region. And in the following slide, I'll talk more about it. So data in the Exadata storage is logically partitioned and cached. Partition in each partition, and the size is 1 MB. The 1 MB area is called storage region, and storage software stores minimum and maximum value for a column. I think this slide will make more sense. So here I have a storage index for a table, and if you see the top storage region says min and max value are 3011, 4119, 411555. So if I'm trying to run a query and if it is using storage indexes, it will just go and touch the region where the data resides. So there will be a separate index for most of the columns. What column it will use to create the index is based on heuristics. And as it eliminates storage regions, the functionality is equivalent to partition pruning. So like in a regular index, you browse through the addresses and go and pick the data you want based on the address. Wherein in this you eliminate it. Okay, I'm looking for XYZ data, and in this storage region, uh, it's XYZ, and it's not XYZ, it's a different range, and so I'll eliminate it and move to the next region. How much benefit you're getting, how much saving you can query $sys stat view. All right. So we are done with the storage indexes. Remember, we talked about some of the problems we have, and after talking about all these new features, let's talk about our business cases again. So one of the business cases was, I want to consolidate multiple databases into one database as a schema consolidation. I have same name of public synonyms in those databases. How do I consolidate? And the option was Oracle Multitenant, because if you are doing a schema consolidation and you have same name public synonyms, then you cannot do that. But multi-tenant, it will separate it uh, logically and physically, so you should be able to use it. I have large table around 1.5. Some of queries do a full table scan. It is not possible in my database. Storage indexes is the solution for this. 50 gig, 20 gig, and 150 M tables, data load nightly, delete data. How do I maintain the indexes? It was very difficult. We can use Oracle InMemory option. We can use InMemory for Active Data Guard. How I can make sure that one runaway query will not take over all my CPU resources? Instance caging, we talked about it. DBRM, we talked about it, and IORM, we talked about it. If we use the combination of these, we can certainly control those runaway queries. Keeping 10-year worth of data as a federal or state regulation, right? You partition it, you compress data using ESCC, and here is the method. Like, it's a sample suggestion, but you can do whatever you want. Say with data older than 3 years, I can use ESCC archive compression, which will be giving me the highest level of compression. 1 year, older than 1 year, I'll use ESCC query high, and remaining data I'll keep uncompressed. We clone multiple environments every month. With growing database size, work window is increasing. You can use Oracle Multitenant to clone. This is thin provisioning of PDB using snapshot copy. So if you're using ZFS, it can be instantaneous. I'm running multiple PDBs in a single CDB, how I can manage resources. We talked about it. So you can control resources using the parameters, then you can control resources using IORM, DBRM, a lot of ways to manage it. We talked about in the previous slide. Large implementation of Oracle Multitenant. Can I control initialization parameters? Yes. So, and if you query $, parameter, and there is a column, is PDB modifiable? If you put in your where clause, is PDB modifiable is equal to yes, it'll show you all the parameters which you can modify on a PDB label. How do I know if I have room for growth in my Exadata? An answer is Oracle Management Cloud, a new thing, but I would recommend you try it. This is really good. You can do your application performance monitoring, infrastructure monitoring, IT analytics, log analytics, and within infrastructure monitoring, you should be able to go and check how much you have, how much you used. Yes. Again, very good place to begin 12.2. Now you have 18C, so So in the same place, you should be able to find it easy documentation. So with this, thank you very much. I we finished just in time. I'll be happy. I'll stick here and I'll be happy to answer any questions you have. Um, Thank you very much for taking time and listening me. On the screen, you see my email address, my blog, my IOG LinkedIn, my IOG LinkedIn page, and my Twitter handle. So follow me. Send me an email if you have any questions. If you do not want to ask now, you can send me an email, and we can take it from there. Do we have any questions on the chat? Let me see if I can. Great. So there is no question at this point, but yes, um, you can send me an email if you have any questions. You can talk to me on a Twitter and be in touch. Thank you very much. Thanks for all your time.